Welcome everyone. Today I will discuss the introduction part of probability. This part, that is probability, plays a vital role. This is most important chapter in mathematics. It is important for every competitive exam, for every exam in service. It has wide uses. So the word probability means chance. Probability relates with a word chance. What is the chance of getting head if a coin is thrown? What is the chance of getting even number if a die is thrown? I'll discuss the definition, but before it, we need some basic concept. Suppose a coin is tossed. A coin is tossed. So what we are getting? Either head or tail. So we get head or tail. We are not sure whether head is appearing or tail is appearing, under the assumption that coin is unbiased. That is, it is free from defect. Now, if a die is thrown, any one of the cases, 1 or 2 or 3 or 4 or 5 or 6 will appear. All of you know it. If a die is thrown, we are getting either 1 or 2 or 3 or 4 or 5 or 6. We are not sure of getting 1 or 2 or 3. That is, it depends on chance. It depends on chance. So, first term, that is random experiment. What is a random experiment? We need to give definition of probability. We need some basic concept. What is a random experiment? A random experiment. So look, this is an experiment. A random experiment is an experiment whose result depends on chance. So look, random experiment. In short, random experiment is an experiment whose result depends on chance. Depends on chance. Chance. This to be noted. Depends on chance. So look, a coin is tossed. Head or tail will appear. You are not sure that head will appear or tail will appear. It depends on chance. So what is random experiment? A random experiment is an experiment whose result depends on chance. For example, I have already given example. So another example, tossing of 2 coins. 2 coins. Throwing off 2 dice. So these are random experiment. So what is a random experiment? Random experiment is an experiment whose result depends on charge. Now, second definition. So, to start trigonometry, we need some basic concept, that is basic definition. Outcomes. So, take an example. 2 coins are tossed. So, we may get 2 heads. 1 head, 1 tail. Tail first, then head. 2 tail. So look, HH is an outcome. HT is an outcome. TH is an outcome. TT is an outcome. So what is outcome? So the result of a random experiment, the result of a random experiment is called an outcome. So for example, when 2 coins are tossed, HH is an outcome. So today I am discussing only the basic concept. So what is outcome? The result of random experiment is called an outcome. Result of random experiment. Then sample space. This is most important to define probability. Sample space. What is sample space? Sample space. So, suppose previous example, 2 coins are tossed. What are the outcomes? I have already discussed HH is an outcome, HT is an outcome, TH, tail first, then head. So these are the outcomes. The set of all possible outcomes is called sample space. So what is sample space? It is denoted by S. So it is set, so it is written in roster form in this way, second bracket, and the set of all possible outcomes. So, sample space. So, this is the most important topic of, definition of probability, that is sample space. The set of all possible outcomes is called sample space. Now, number 2, when 3 coins are tossed, so what are the sample space? S equals to. So 3 heads. First, second, third. Then 2 heads. Look, HHT. HT, H. THH. Look, 2 heads. HHT, HTH. So position of T only changes. How many cases? 3. Then 2 tails. So TTH, THT, HTT, and 3 tails. So TTT, TTT. So you are getting 1, 2, 3, 4, 5, 6, 7, 8. So 8 possible cases. You know it. If a coin is tossed one time, so total number of sample space is 2 to the power 1. That is 2. Then if a coin is tossed 2 times, then total number of sample space is 2 square. So for example 1, 2 square 4. And if it is tossed 3 times, then 2 to the power 3. Similarly, if a coin is tossed n times, if a coin is tossed n times, then total outcomes, so 2 to the power n. For 1, 2, for second time it is 2, for third time it is 2, for n times it is 2. So by fundamental principle of counting, 2 to the power n. This is result of permutation and combination. Now we are discussing the basic concept, introductory. So it is of class 10 and 11. Now number 3, when 2 dice are thrown, so 2 dice are thrown, find sample space. So I have already discussed, when a die is thrown, sample space is 1, 2, 3, 4, 5, 6. So 6 possible cases. So 6 to the power 1. 6 faces and it is thrown one time. So 6 to the power 1. But look, 2 dice are thrown. Find the sample space. So if 2 dice are thrown, this is most important result. So what is the sample space? So 1, 1. First. So this is 1. In second times it is also 1. Then 1, 2. 1, 3. 1, 4. 1, 5. You have to recall these results. Then 2 first. 2, 1. 2, 2. 2, 3. 2, 4. 2, 5. 2, 6. 3, 1. 3, 2. 3 first. 3, 3. 3, 4. 3, 5. 3, 6. 4, 1. 4, 2. 4, 3. 4, 4. 4, 5. 4, 6. 5, 1. 5, 2. 5, 3. 5, 4. 5, 5. 5, 6. 6 at first, then 6, 1. 6, 2. 6, 3. 6, 4. 6, 5. 6, 6. So these are the possible cases. So second bracket, then second bracket close. How many cases? 36. So 6 to the power 2. 6 to the power 2. So when 2 coins are tossed, so what are the total number of sample point? 6 square 36. So if 3 coins are tossed, then total sample point 6 to the power 3. 2, 1, 6. So it is not easy to write. So we only remember what are the sample points. So two dice are thrown, find the sample space. So this one is sample space. So sample space we are discussing today introductory part, that is some basic definition, a random experiment, then outcomes, then sample space. Then number 4. 4 coins are tossed. 4 coins are tossed. You have to remember up to this. Find sample space. Sample space. So 4 coins are tossed. So I have already discussed head and tail. So it is 4 times. So how many cases? 16 possible cases we are getting. So what are the cases? 4 head. Then 3 head. 3 head. H, 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 T. Then change the position of tail. So 4 heads, then 3 heads. Then 3 tails, TTH, THT, sorry, TTTH, TTHT, THTT, HTTT. So how many cases? 3. Then 2 head. 2 head or 2 tail as you please. So HHTT. HT, HT. So you are getting 6 cases. So you know 4 total, then 2 head, 2 tail. This is result of combination. So 24 by 6. So 6 possible cases. So HHTT, HT, HT. So TH, TH. Then THTT. So TT, HH. TT, HH. HHTT. So we have 1, 2. This is HTTT. Then H, H, T, T, H, T, H, H, T. How many cases we are getting? 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Then 4 tails. So look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 2 to the power 4, that is 16 possible outcomes. So you recall in this way 4 heads. 3 heads is simple, only position of tail is changing. Then 3 tail is also very simple, 1, 2, 3, 4. Now 2 head, 2 tail. So position of head and tail will be changing. Then 4 tail. So 2 to the power 4 equals to 16. 16 possible cases. Now number 5. I am discussing sample space. From a group of 2 boys and 3 girls, 2 are selected. 2 children are selected at random. Find sample space. So 2 boys, suppose boys are denoted by B1, B2 and girls are denoted by G1, G2, G3. So 2 are selected. So if you know permutation and combination, then it will very easy to know what are the total number of sample space. So total person is 5 and you have to take 2 at a time. So 5 C2 is equal to 10. So A is equals to, you are getting 10 sample point. So look, out of 5, 2 to be selected. So number 1, both are boys. Number 2, both are girls. So G1, G2. G1, G3. Then G2, G3. Both are girls. Then 1 boy and 1 girl. So B1, G1. B1, G2. B1, G3. Then B2, G1. B2, G2. B2, G3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you are student of class 10, you have to write in this way. Thinking 2 boys, 2 girls, 1 boy, 1 girl. Now if you are student of class 11, then you can find the sample point using permutation and combination. Today I will discuss only sample space. Now number 6. I will take 3 classes for introduction part of probability. A coin is tossed. If result is a head, a die is thrown. If die shows up, even number, the die is thrown again. The die is thrown again find the sample space. Find the sample space. So, look at another problem. This is a typical problem. A coin is tossed. So you may get head or tail. So if result is head, then a die is thrown. So if result is tail, so it stops. If result is tail, then we are getting T. Now if result is head, a die is thrown. If die shows even number, then another die is thrown. Find the sample space. So first one is a coin is tossed. So you may get head or tail. If it tail, then it stops. But if it is head, if result is head, then a die is thrown. So what are the sample points for die? 1, 2, 3, 4, 5, 6. So if die shows up even number, so if it is odd, suppose H1, then H3, H5, it stops. Because if it is odd, there is no option here. But it is given if die shows even number, then again a die is thrown. Find the sample space. These to be noted. So head, then even number. If it is even, then a die is thrown. So you may get H21, H22, H23, H24, H25, H26. Why? You look. Even number, then a die is thrown. It may be 1 or 2 or 3 or 4 or 5 or 6. Then even number is 4 also. H42, H43, H44, H45, H46. Then H61, 62, 64, 63, 864, 865, 866. So these are the possible cases. Now listen again. A coin is tossed. If result is a head, a die is thrown. If die shows up and if result is head, if result is tail, so no cases. So first one is tail. If result is a head, then another die is thrown, and if it is even, then again a die is thrown. So head, a die is thrown with odd number. So H1, H3, H5. But even number if you are getting, then another die is thrown. So you get H21, H22, H3, H24, H25, H26, and similarly this. So this is sample space. Next, we are discussing sample space because it is the most important part to define probability, to solve problem of probability. Now, problem number 7. A coin is tossed until a head comes, until a head comes. For the first time. Find the sample space. Find the sample space. A coin is tossed until a head comes. So a coin is tossed, you may get head or tail. But look at this is typical problem. A coin is tossed until a head comes. So look, head or tail if you tossed it one time. But this is rejected because your main aim is to get head. So A is equals to sample space. So if we get head, then it stops. Mind it, the process is repeated. The process is repeated. A coin is tossed repeatedly. Now, if it tail, then you have to take another chance. So, then we get TT and TH. But you have to get head. So, this one is PH. Head first, it stops. First one is tail, then head, then TTH. If you get head, then it stops. Your main aim is to get head. Then TTTH, TTTH, and it will continue. So this is an exceptional example. Here sample space is not finite. Look, head, then stop. If it is not head, first time tail, then head, TTH, TTH, TTTH, and so on. So the process will continue. So this is example of sample space whose sample point is not finite. So today I have discussed some basic result of basic definition of probability. So it is not completed, only 3 definitions. So random experiment, outcomes, and samples. So today I have discussed only the main part, sample space. In next class I will discuss the another basic concepts, that is what is event, what is exclusive event, exhaustive event, and so on. From next class I will start basic concepts of probability, remaining basic concept of probability. I will take 3 classes to define probability. So thank you for today.